Improper integrals. What's so improper about them? No, it doesn't mean my horribly drawn integral symbols. You know what, actually, I take that back. This looks pretty good. An improper integral is the definite integral of a function where one or both of the limits of integration are undefined. For example, the integral of a function from 0 to infinity. This is improper because you can't go about evaluating a function at infinity. You have to take the limit and see if an improper integral will work out to something useful. Let's replace the term here with n, and then put the integral in the limit as n approaches infinity. Now we can just evaluate this definite integral with that variable n. So it will work out to be the antiderivative of the function with the difference between those two limits of integration. In order for this to work out to a definite answer, the antiderivative has to go to some finite value as n approaches infinity. Now let's try this for f of x equals e to the negative x. We'll try to take the area under the curve from 0 to infinity. So we can create a limit with n approaching infinity, replacing the infinity in the integral with n. And now we can find the antiderivative of e to the negative x, which just how happens to be negative e to the negative x. You might understand at this point why I always use e to the x as an example. So for the lower limit of integration, 0, this evaluates to negative 1. The limit as n approaches to infinity for negative e to the negative x just gets smaller and smaller as x gets bigger, so we can say that that limit is 0. So these negatives here cancel out, and the solution is 1. So there's another situation where you need improper integration, where you're evaluating an area under a line that approaches infinity. For example, f of x equals 1 over x. If you evaluate this function as it crosses over 0, you've got to apply the same limit but with 0. Now we can then just solve this the same way we did our last example. We can take the antiderivative now, and we get the natural log of 1 minus the natural log of 0. But as you realize quickly here, the natural log of 0 is undefined. You can't find a value to exponentiate e by that will equal 0. So in this case, we can't get a finite solution to the area under the curve. In simple terms, there is an infinite amount of area under this segment of the curve. In other cases, you will be able to find a finite area under discontinuity in a curve, such as 1 over the square root of x. But I think you get the idea, and you can try to solve this one yourself. One common question on the AP test will be asking you to figure out if an improper integral is defined or undefined, sometimes without actually requiring you to solve it. So it's a good thing to learn quickly the difference between the two. So those are the two cases where improper integrals are important. However, you might run into an integral that crosses over an infinite discontinuity, or with two improper limits of integration. In this case, you just need to break up the integral, which, as you recall, looks just like this. So if we took the integral of e to the negative x from negative infinity to positive infinity, we can just make it the sum of negative infinity to 0 and 0 to positive infinity. Or if we have an integral of 1 over x from negative 1 to 1, we can break it up into two integrals from negative 1 to 0 and 0 to 1 respectively. So that's improper integration. It's fairly straightforward. It will come up later in infinite series. The next video will be starting on how to understand and use infinite series, so hopefully you won't have a sudden and massive stroke while taking the AP test.